Okay, so we're going to talk about section 11.9, differentiation and integration of power series. How do we do this? We do it term by term. Okay, so we're integrating term by term. We're taking the derivative term by term. So we can do this by differentiating or integrating each term individually. So here's the theorem. Very cool theorem. If a power series n equals 0 to infinity of a sub n x minus c to the n. So this is a power series centered at c, and it has a radius of convergence r, which is, we'll assume, greater than 0, then what's true? The function f defined by f of x equal to the series n equals 0 to infinity, a sub n, or a n are the coefficients of the polynomial, x minus c to the n, which is a 0 plus a 1 x minus c to the 1 plus a 2 x minus c to the 2 and so on forever, okay, is differentiable and therefore continuous. If it's differentiable, then it's continuous. Get that for free. On the interval of convergence, C to R, C minus R to C plus R. That interval of convergence. And what do we have here? So two things. Number one, f prime of x, so the derivative of this function is the derivative of the series. Didn't realize a couple months ago you'd be taking derivatives of series, huh? Okay. So what does this equal? Well, this is equal to the series as n goes to 0 to infinity. My derivative comes inside d dx an, the coefficient, x minus c to the n. Okay? Now, at n equal to 0, all we have is this term a naught, which is a constant, and so the derivative of a constant is 0, okay? So that first term, n equals 0, ends up going away, okay? So we start at n equal to 1 and go to infinity. Now the derivative, I'm taking the derivative with respect to x, so the constant an comes out front. Really the only thing I'm taking the derivative of, I'm using the chain rule, x to the n, right? So the an comes out front, okay? Since it's a constant, it can come out in front of the derivative. And the derivative of x minus something raised to the n is what? Well, chain rule says it's the derivative of the outside, n times x minus c raised to the n minus 1, times the derivative of inside. Derivative of inside with respect to x is just 1, okay? So this right here, my friends, is the derivative. How do I write this out? This is what? Plug in 1. I have a1 times 1, what? And then times x minus c to the 1 minus 1, which is 0, so that goes away. And then plus a2 times 2, what? X minus c to the 2 minus 1, plus a3 times 3, x minus c to the 3 minus 1, and so on, right? So what's going on here? This equals a1 plus 2 a2 x minus c to the 1 plus 3 a3 x minus c to the 2, and so on, okay? You guys see how if I look at this function up here and I take the derivative term by term by term, what am I getting? Well, this is 0. This derivative of x is just 1, so that's plus a1 times 1. And then chain rule, bring the 2 out front, 2a2 x minus c to the 1, and so on. Y'all see how this is the same thing here? Right? So this, my friends, is what's happening. The first term, the a0 term, is a constant. The derivative of a constant is 0, so that first term goes away. Now, we can do the same thing with integration. So the second part, integration. With integration, I can integrate f of x dx, and this is equal to the integral of the sum in going 0 to infinity of a sub n, x minus c to the n, close it, dx. Okay, so the integral of the sum is the sum of these individual integrals. My goodness, that's like a tongue twister, right? So what does that equal? That's the sum as n goes to 0 to infinity of the integral an x minus c to the n dx. So we integrate each term individually. Now to integrate something to the n, I do what? I take, all right, so I have n equals 0 to infinity. I don't lose a term because I'm not taking a derivative, I'm integrating, right? I have an, which is my constant, right? The an can come out front. Now, how do I integrate x minus c to the n? Well, that is x minus c to the n plus 1 divided by n plus 1, okay? That integrates, but then when you integrate, remember you have a plus c out to the side, okay? So you have all this and then plus c, your constant. So what does this get me whenever I integrate? Well, I get c plus, and then when n equals 0, that's a0, x minus c to the 0 plus 1 over 0 plus 1, and then plus a1 x minus c to the 1 plus 1 over 1 plus 1, and so on, right? So what does this equal? This is c plus a0 x minus c plus a1 x minus c squared over 2 plus a2 x minus c cubed over 3, and so on. Okay, so how did I get this right here? You can integrate. If you integrate each term individually, you get to this here. So if I integrate a0 with respect to x, when I integrate a0, I get x minus c to the 1 over 1. When I integrate a1, I get a1 x minus c to the 2. I add 1 to it, and then I divide by it. And then I just keep going. So I integrate each term individually. But also when you integrate, you have that plus c, that first plus c there. Okay? So you only need 1 plus c. All the other constants of integration are integrated into the 1 plus c. Okay? So the key here to remember is that the radii of convergence of the power series are both r. okay? The radii of convergence for the power series for the integral of the power series and the derivative of the power series are both r. Okay, not the interval of convergence, but the radius of convergence is both r. Now, what happens potentially is the interval changes. So a note for you, the interval of convergence can change. When you take a power series and you take a derivative of a power series, what might happen when you take a derivative is you might lose the endpoints, where it might converge at the endpoint. When you take the derivative of that power series, now all of a sudden you might lose your ability to count the endpoint in your interval of convergence. So for example, the original series may converge for, including 0 up to 1 open parentheses. So maybe this is the original, okay? But now, maybe you differentiate the series, okay? You could lose convergence at the endpoint. Okay? What does that mean? That means all of a sudden, your interval of convergence might look like this. Okay? So if you differentiate, you could lose an endpoint. On the flip side, if you integrate, while integrating the series, you could gain convergence at the endpoint. So instead of, losing it, maybe you're all of a sudden now you might have interval of convergence here at this endpoint. So integrating the series causes you to potentially gain convergence, whereas differentiating the series causes you where you might lose convergence at an endpoint. But no matter what, the radius of convergence is always going to stay r. So if you started with your original series had a radius of convergence r, then when you integrate, you're going to have a radius of convergence r, and when you differentiate, you're going to have a radius of convergence r. So it's only the interval of convergence that might change when you start differentiating or integrating term by term. Okay, so I wanted to show you that scenario, and what we're going to do is we're going to work one example, okay? So what I want to do is I want to start, okay, with express 1 over 1 minus x all squared as a power series, okay, by differentiating one over 1 minus x, okay? And then the question is, what is r? All right, that's what I want to know. What is r? All right, so what do we know about 1 minus x in the denominator? Okay, So if you think about this thing right here looks very much like your a over 1 minus r, which is your geometric n equals 0 to infinity a r to the n, okay? So, but instead of being a, what do we have? We have 1, all right? So we have 1 over 1 minus x. So what does that look like? Well, everywhere I see an a, what am I going to replace it with? I'm going to replace it with 1, so this is 1 here. And everywhere I see an r, what am I going to replace it with? I'm going to replace it with x. So I have x to the n right here. Not too bad. So what does this tell me? This is what? This is 1 plus x squared plus x cubed plus x to the 4th. Now the only way that this is going to converge, okay, geometric, what do we know? Converges for what? Absolute value of r less than 1, right? So that means as long as we're between -1 and +1, we converge. That's my interval of convergence, right? We've already gone through that with our geometric series. So my interval of convergence is what? It's -1 to +1. So the intervals are open-ended intervals, all right? So that's an open set right there between -1 and 1, all right? So what do I want to do? I want to express this as a power series by differentiating this thing right here. So how do I take the derivative of that? Okay, the derivative, d dx, 1 over 1 minus x. What's the derivative here? Low d high, so low d high minus high d low all over the square of what's below. Okay, so that goes to 0. This is 1 over 1 minus x all squared. Does that look familiar? That's exactly what I want here. Okay, so all it amounts to doing, since I know that 1 over 1 minus x is equal to the sum 0 to infinity of x to the n, then if I take the derivative of the left side, I need to take the derivative of the right side. And the derivative of the right side, I take the derivative of each term individually. And so this is the sum in going from 0 to infinity of what? d dx, x to the n, which is equal to the sum in going from, well, let's just play this out and put 0 here and just see what happens, right? So this is what? N x to the n minus 1. That's the derivative of x to the n with respect to x, right? Well, when I plug in 0 for that first term, so let me copy and paste this, right? So let's move this over here. So when I plug in 0, I get 0 times x to the what? 0 minus 1 plus 1 times x to the 1 minus 1 plus 2 times x to the 2 minus 1 and so on, right? What happens to that first term? That first term goes away, okay? So that n equal to 0 goes away. N equal to 1 is just 1. And then n equal to 2 is just 2x. And then what? 3x squared and so on, right? So really, this series is equal to n equal 1 to infinity of n x to the n minus 1, okay? So what I wanted to do here is I wanted to represent this as a power series, okay? So what do I know? This is equal to 1 over 1 minus x squared which is a series n equal 1 to infinity in x to the n minus 1. All right? Now, what do you know from the theorem we just figured out? Well, they want to know what r is, the radius of convergence. Well, it doesn't matter if I take a derivative of the series or the integration, or I integrate the series, they are both going to have the radius of convergence that was the same radius of convergence of the original. And remember, we discussed this was a geometric. So the radius of convergence here, you think about an interval, right? With zeros in the middle, 1 over here, negative 1 over here. Your radius of convergence, r, is equal to 1, okay? So you can run through the test if you'd like, but you're still going to get a radius of convergence of 1, okay? They weren't asking for interval of convergence here. They were just asking for radius of convergence. But since we know that differentiation, potentially you lose the endpoints on your interval of convergence, and our endpoints, we already don't have the endpoints included, right? So can I lose anything? No. So by logic, I already know, and you can run through this and check yourself, but I know that the interval of convergence is -1 to +1, okay? So kind of interesting thing going on there. So you gotta be careful with that. Let's do one where we integrate. Okay, so evaluate the integral from 1 over 1 plus x to the 7th dx as a power series. Now, this integral, if you try to do this integral at home, oh my goodness, good luck. All right, we've got a lot of tools in our tool belt, but none of our tools can help us with this until now. The only way we can integrate this bad boy is through taking advantage of power series. Now, anytime I see something where it's like you got like a number and another number and then your variable over here, I'm thinking geometric, a over 1 minus x or 1 minus r, geometric thing going on here. 0 to infinity, a, r to the n, okay? This is going to be your best friend, right? Absolute value of r less than 1, okay? So how do I make this look like that? Algebraically, we're going to have to use our thinking cap. The a is 1, we're good to go there. But I have what? I've got a minus r here and I have a plus here. Well, how do I turn a plus into a negative? Well, to do addition via subtraction, we have to subtract a negative, okay? We have to subtract a negative. And now we're in the form a number over 1 minus, and then we got some variable in here, okay? That's the form that we're looking for, okay? So however you have to do that, I don't care, but that's what your goal is. Your goal is to make it look like this. You want it to look, ooh, right? Wow. Okay, you want it to look just like that. Okay, so what's going to happen here if it looks just like that? The series a here, a is equal to 1, and r here is equal to negative x to the 7th. So we have 1 and then negative x to the 7th raised to the n. So what does this look like when I do some algebra here? This is the series n going from 0 to infinity. Now this negative, I can pull the negative out because that's like a -1. So that's -1 raised to the n times, and then think about this, x to the 7th raised to the n, power to a power, I multiply, so this is to the 7n here, okay? So this is my new series, all right? And what am I wanting to do to my new series? So I have 1 over 1 plus x to the 7th equal to the series n equals 0 to infinity, negative 1 to the n, x to the 7n, okay? So what am I going to do here? Well, I wanted to integrate, right? So if I integrate on the left side, integral with respect to x, I integrate on the right side too, okay? And so now I'm going to integrate term by term. So I have series 0 to infinity, okay? And then anything that doesn't have an x in it, I can pull it out front. I don't have to worry about that part there, right? So the negative 1 to the n has no x. It's like a constant. Pull it out. I have x to the 7n dx. Now, how do I integrate x to the 7n dx? This really isn't that bad. It's a polynomial, so I use my polynomial rule. And what does the polynomial rule tell me? It tells me what? It tells me that I take x to the 7n and I add 1 to it and I divide by it, 7n plus 1. Now, when I integrate, I also get some plus c over here. Okay, so I get an extra plus c factor. So this is my answer. My answer is what? It's c plus, well, when x equals 0, when n equals 0, I get x to the 1 over 1, so that's just x. And then, so then that makes this piece positive. All right, let me just write all that out instead of doing it in my head. Okay, so negative 1 to the 0, x to the 7 times 0 plus 1 over 7 times 0 plus 1. Then plus negative 1 to the 1, x to the 7 times 1 plus 1 over 7 times 1 plus 1. And then plus negative 1 to the 2, x to the 7 times 2 plus 1 over 7 times 2 plus 1, and so on, right? So if I simplify this, this is c plus x minus x to the 8th over 8 plus x to the 15th over 15 minus x to the 22 over 22 and plus, and so on and so on, as long as what is true? Well, the interval of convergence here, all right, you think about a geometric, when will the geometric converge? When that ratio is less than 1, so that negative x to the 7th is less than 1, okay? Absolute value kills the negative there. So when is that true? That's true for x between negative 1 and 1, okay? So this is true. So I'm going to say converges for absolute value negative x to the 7th less than 1, which implies, you know, absolute value of x is less than 1. So the interval of convergence goes from negative 1 to 1. Okay? Now, that tells me the domain of this function, right here, is only these values here. So the integral only works, it's only valid between negative 1 and positive 1. So there's some restrictions on this, but it gives us a way to integrate something that's impossible to integrate. Now we can integrate it and get as accurate as we want by taking out however many terms we want to take out using some computer. Computers are very good at adding, subtracting, multiplying things very quickly. Okay, so this is how your computer would estimate this integral that you can't find a closed form solution for. Pretty interesting idea on how to integrate things, because not everything's integrable, you know, except you think about differentiating. We can take the derivative of anything that we want, right? We just follow the rules. Okay guys, hopefully this video was helpful.